All right, so this is the second video on dihybrid crosses, continuing our understanding. In the last video, we talked about what the dihybrid cross was and how it relates to Mendel's law of independent assortment. We also determined how we can find out the gametes for an individual with a dihybrid cross. The gametes for this individual will be big T, big G, big T, little g, big G, and little t, little g. And let's say our true dihybrid cross, we are crossing two individuals that are both heterozygous for both traits. You'll notice they have the exact same genotype, in which case this individual also has the gametes that the other one has. All right, so now that we know what possible gametes these individuals can make, how do we figure out what possible babies these can make with all of the, random fertilization that can happen? That's where our big Punnett square comes in. And so we will put the gametes from one individual on one side, just like we did before. And we will put the gametes from our other individual on the other side. All right, and then we fill in just as before. Certain things we bring down, and the horizontal ones we bring across. However, watch how I do this. Just like before when we were writing their genotypes, notice how I kept the T's all together and the G's all together. It's not TG, TG. So that's how we're going to do this. So I'm going to look at the T's first here. You know what? I'm going to do everything in a different color. So notice I used both options from each parent combined, but I still ordered them the two T's first, the two G's second. And now we're just filling in this table. And this is going to be one of those things where you have to watch very carefully which row you're in, which column you're looking at, what will come first. Remember, as always, we're keeping the two T's together, the two G's together, but no matter which parent it comes from, a dominant letter comes before a recessive letter if there is a recessive letter. And notice also here, even though, I'm just going to stop for 1 second, even though we have a total recessive individual, the T's still come first because that is the order that we started with our original parents. So whatever order the parents are in is going to be what you want to keep your offspring in. If it was tall, then green, you want to do height, then color. If it was green tall, you will do color, then height. Okay, so we're finished up with this, and now here comes this sort of analysis part. I'm going to move just a little bit to the right. Because this is a true dihybrid cross, it has a certain property, or certain properties, with its phenotype ratio. Okay, you will notice that there are going to be basically 4 options for phenotype. I'm going to move over just a tad. There are going to be 4 options for phenotype. There's going to be tall and green. Basically dominant for both traits. There's going to be short and green. So if I color code, right, dominant, dominant, or recessive dominant. I can also be tall, or they can also be tall and let's just say it's yellow is the other color. So that would be another recessive dominant, but the opposite from before. And then last but not least would be short in yellow. So that would be both recessive. So we have two dominants, one dominant, one recessive, the other dominant, other recessive, and then two recessives. So let's just count and notice there are 16 boxes, right? 4 by 4. Let's count how many tall greens we have. Let me get sort of a different color in here. Tall green, so that's anything with a capital T, capital G. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's all of them. 9 tall and green plants. Next is going to be short and green, so those are going to be things that have 2 little t's and at least 1 capital G. So that's 1, 2, 3 right there. 3 short and green, tall and yellow. So that's anything with at least 1 capital T, but must have 2 little g's. So that's 1, 2, 3. Another 3 here. Then short and yellow, my only box left here is just that 1. And you'll notice if I add these up, 9 plus 3 plus 3 plus 1 gives me 16. And I know that I had 16 boxes in my 4 by 4 Punnett square, so I know I've counted everything. And you'll find that in a true dihybrid cross, when you're crossing 2 individuals that are both heterozygous for both traits, you will always get this phenotypic ratio, 9 to 3 to 3 to 1.